of e to the x plus 1 over e to the x, and then a dx at the end. Okay, so Erin, you looked at this question, and what were your thoughts?
I first tried to use the substitution with e to the x plus 1.
Okay, so an idea of, well, let's let u be equal to e to the x plus 1. And this seems reasonable because at this point, when you take your derivative, the derivative is e to the x, and so we have dx is equal to du over e to the x. And I do see an e to the x here as well. And so when I go ahead here and I write this down as u over e to the x, replace my dx with du over e to the x, then I get sad. Because at this point, these aren't going to cancel because that e to the x that was left over was in the denominator. And so life is not so good right now. Okay.
Just making it separate fraction. So e to the x over e to the x plus 1 over e to the x.
Okay, so this idea maybe didn't quite work out. And in fact, actually, if this had been flipped over, then your choice for u would have been a really good choice because then this guy would have been on top and they would have canceled nicely. And so in this case, the u substitution isn't going to work so well right away. Okay, but a good idea for this, and Dennis, is that right? Okay, so Dennis is asking, well, maybe if we instead start with the integral of e to the x plus 1 over e to the x dx, and that u substitution didn't work right away, but maybe some algebra will help us here. So we can simplify, we can distribute, and one thing that's nice is we can distribute because there's only one term in the denominator, and anytime there's one term, it's easy to distribute it to different parts of the numerator. That doesn't work so well if it's flipped the other way. Okay, so we'll write this down as e to the x over e to the x, which is 1, plus 1 over e to the x dx. And so now life is a little bit better. This 1 over e to the x, I don't like that too much, and I don't know how to deal with fractions. I mean, I don't have a quotient rule for antiderivatives. So one thing that I might do is maybe rewrite this guy and make it look a little bit nicer with no fractions. So I can do that as e to the negative x. So I have 1 plus e to the negative x dx, the integral of all of that stuff. Okay, now at this point, life becomes a little bit better. I have two choices. One is if I want to, because of the plus sign, I can separate this into two separate integrals. I don't necessarily have to. But the part that bothers me a little bit is this e to the minus x. I know what the antiderivative of, let's see here, my thought here is that I know that the antiderivative of e to the x is just e to the x. But e to the fancier stuff, I may want to do a u substitution. And so because this inside stuff up here is fancier than just an x, u substitution is going to come into play. So we do want to do a u substitution on this problem. It's just that it shows up in a slightly different place than you might initially think.
Negative x.
Yeah, so we're going to choose our u to be our inside function, which is the power on the e. So we'll let u be equal to negative x. And so then our derivative, du over dx, is negative 1. And when I solve for dx, I get dx is equal to du over negative 1. Okay, so writing this out, we've got the integral of 1 plus e to the u. This light is still flashing. Flip it off. Can everyone still see that okay? Okay, great. Okay, so we have 1 plus e to the u, and that dx I'm going to replace with du over negative 1.
Could you just put negative du?
Absolutely, that's exactly the same thing. Yep. Okay, so life is good. We've gotten rid of all of the x's. Are there any questions on getting to this point? Okay, so the next thing is, again, this du over negative 1 is the same thing as negative 1 times du. Either way, I'm going to pull that negative 1 to the front. And so technically, I'm only going to write this in the technical way just this one time. It's really 1 over that value on the bottom. With the -1, it doesn't matter, but if that were a 2 or a 5, it would make a big difference. We'd be pulling out a 1/5 rather than a 5. So we have 1 over -1 times the integral of 1 plus e to the u du. Now, here's another asterisk that you may want to consider here. Because we have changed our integral in terms of u's, when I take my antiderivative of the constant, my antiderivative is going to be a u rather than an x. So I've got a u plus the antiderivative of e to the u is e to the u. And then a plus c on the end. Alright, now final step. Once we've taken our antiderivatives, plug back in our x's. So everywhere that I see a u, I'll put back in the negative x. So I've got negative x plus e to the minus x plus c. And this is a perfectly legitimate final answer. Yes?
So when you're writing dx is equal to du on the first, no, all the way to the
Oh, over here.
yeah, that dx is equal to du over e to the x.
Yes.
So would you be able to write that 1 over e to the x du?
Absolutely. You could write this as dx is equal to 1 over e to the x times du. Yep, absolutely.
So like from there, you don't want us to distribute the negative?
That's totally a personal preference, and I don't personally care. It's up to you.